So now let's look at it from a graphing perspective. Let's look at limits from a graphing perspective. Pass it back. All right, so looking at this handout here, we draw the top graph of this handout. Not as nice as the printout there, but hopefully read that okay. All right, so let's think about then, so this is my function, y equals f of x, function we'll call it. All right, so number one, what's the limit as x approaches 2 from the left, little minus, f of x? Based on that graph, so I don't have a table here, I just have the graph. I don't know that function, what it is, so I'm not going to be able to provide a table here. But I don't need it, because I know what this means. This means I'm approaching x approaching 2, and I'm looking at the function values as x approaches 2, and again, that's from the left. So what part of the graph am I looking at? Well, as x approaches 2 from the left, I'm looking at this part of the x value, but graph-wise, I'm looking at this piece, right? What's happening as x approaches 2, so what's happening is the function is getting closer and closer to that little circle there. Now, the grab my bag here. See that? That looked closer. That one's all covered up. Do you mind if we pull you closer? Nope, can't do that either.
Plug into the power box.
Okay. Do you see it?
Yeah.
Thank you. All right, back in business. Thank you. Okay, so we are looking at the limit as x approaches -2 for our function here. We've got graphs. So what happens as we approach 2 in the x range? What happens to the function value? Well, the function values, of course, are the y values. And so what do we see those y values approaching as x approaches 2? Well, it looks like they're going up, like I said, going up to that little dot there of 3. It looks like the function values are getting closer and closer to 3. You with me on that? Now, on the other hand, what's the limit as x approaches 2 on the plus side, the right? Well, we're looking at approaching 2 from the right, so that's from the greater than side, so I'm getting closer and closer to 2 from the right. Well, that's talking about this piece, isn't it? And so what, as we go closer and closer to 2 there, looks like these function values are getting closer and closer to this little circle here, which, now, on the handout there, It looks like it's close to 1, but wouldn't you say it's a little bit lower than 1? Let's call it 0.9. If you said 1, I'd be okay with that. On the handout, it looks like those values are closer and closer to 0.9. A little lower than 1. Is that okay? Well, although both of those in combination then, what would you say the limit as x approaches 2 is? Which side you're going to choose for 2? We don't really choose a side, you look at both sides. From the left it's 3, from the right it's 0.9. So what does that mean for this? It does not exist, right? D and E? Because they don't match. All right? Is that okay? Now, another issue here. What's the limit as x approaches, I meant that to be right above 5 there. Yeah, those should be lined up with 5 there. So I didn't have a limit as x approaches 2, I didn't have from the right and left, but do I have a limit as x approaches 5? I think so. As x approaches 5, either side, if I look at approaching 5 from the left, approaching 5 from the right, either side, I'm coming in to this part. So what's the limit as x approaches 5? Well, it looks like it's that circle right up here. My graph's a little off because that looks like it's pretty close to 2 there. So that one does have a limit as x approaches the 5. However, we talked about another one, similar one, earlier. What's the actual function value at 5? Well, the actual function value at 5 is what happens at 5. And what happens at 5 as far as the graph is? Well, the function value at 5 is right here. Just 1. See the difference? The function value is what happens at 5. The limit as x approaches 5 is what happens as you get closer and closer into that. So you have to be, like I said, it's a little, that's a little confusing. Okay? All right. Now, a couple of other things. To consider. Before we head out here, let's talk about infinite limits. For just a second. If I look at the limit as x approaches 0 of 1 over x squared, well, we could play the same game, going back to tables here again. Let's look at what happens to my function values as x approaches 0 from the left and from the right, how we call it. So from the left, the negatives, 0.1, negative 0.01, negative 0.001. We look at it on the right. Positive 0.1, positive 0.01, and positive 0.01. Okay? Well, we can do those pretty easily, but let the table do our work. The negative 0.1, we've got 100. Then at negative 0.01, we've got 10,000. Now, on the negative 0.01, it says 1e6. Are you familiar with what that would mean? That's kind of scientific notation, or the calculator's version of scientific notation. 1e6 would mean 1 times 10 to the 6, and you could probably arrow over it, so it's 1 followed by 6 zeros. So that's followed by 6 zeros. That is 1 million. Yeah, 1 million. And I believe, yeah, we get the same answers on the positive side here, the right side. Anyway, yeah, we do with the table there. What does it look like these values are doing? Well, they're not going to a specific value. They're just getting bigger and bigger and bigger. They're getting bigger and bigger and bigger, larger and larger and larger, aren't they? This is an infinite limit. These are going to, we call it infinity. Infinity symbol there. We would use that. So an infinite limit is just where you have the function values just growing larger and larger and larger, or you could have it go to negative infinity if they do that. But yeah, so this is what I mean by an infinite limit, one that just keeps growing larger and larger, either on the positive side or the negative side there. So this limit is negative infinity. And you can do the left and right thing as well. Well, just thinking back, that original function, let's talk about x going to -2. Well, let's go from the left there. If I do the limit as x approaches -2 from the left, what do we get there? Okay, so it's x minus 2, should have left it in there. X minus 2 divided by x squared minus 4. Table. All right, so what values, if I want to approach -2 from the left, what values would you be looking at there? So -2, I want to approach from the left. -1.9, -1.99, -1.999. Try those. Okay, so those, looks like those are going to infinity also. Not as quickly as that one, but yeah, it looks like those go to infinity. Well, what about the limit as x approaches 2 from the right? Well, that would be, so I'm approaching, -2 from the right. So I approach -2 from the right, well that's -2.1 to -2.01, 001. I did those backwards, didn't I? No. I did those just backwards. Because this side, this would be -1, so okay. I mixed those up. This is this one. So that's it. This one is this one. Is that too confusing? I did those backwards. You see that? Because if I approach -2 from the right, from this side, that's going -1, so it'd be -1.9, -1.99. I did those just backwards. So this one is infinity. This one is when I do it this way, so that's going to give me a -2.1, -2.01, -2.001. That's going to give me the negatives. So that was negative infinity, we would call it, because it's getting larger and larger in the negative sense. Sorry about that. Is that okay? Same idea. Then, so thus, now in this case, we wouldn't have a limit as x approaches just -2 because one's infinity, one's negative. Now to finish this off, this infinite limit, then, well, a couple other things. Let me talk about this one real quick. If I want to do the limit as x approaches pi over 2 of secant of x, if I want to do the trig functions where x approaches a pi number, and let's do from the left again. Here's what you can do if we want to do a table. So x approaches pi over 2. Well, I guess there's different ways, but let's think of pi over 2. Isn't that the same as 1/2 pi, which is the same as 0.5 pi? And you could do this the same thing for any. If I did it for pi, I could do 1 pi. But what I'm trying to get at is, instead of approaching, a number, because pi is a irrational number, it doesn't have a terminating decimal. Let's focus on this number and approach, incrementally that number. So if I approach 0.5 pi from the left, I could do what? A 0.49 pi, a 0.499 pi, and a 0.4999 pi. You see what I'm saying? Approach that 0.5 part from the left. And if I was doing it from the right, 0.51, 0.501. With me there? Okay. The other thing is, what's my function? Well, it's secant of x. Most graphing calculators do not have the sequence and the cosecant. So what I have to use is the reciprocal of secant, which is 1 over the cosine of x, which those, if you've forgotten those, they are in the reference pages in the book, if you have the book there. The reference pages at the back, I think they have little gray edges, some other color edge, but anyway, use the reciprocal there. So I'm going to put in 1 over cosine of x to do this. And again, be sure your mode is in radians. And do 0.49 pi. Oh, okay. Go to the table. 0.49 pi. 0.499 pi. 99 pi. And that gives me 31836, 31.836, 318.31, and then 3,183.1. And so, yeah, those are going to infinity. So, anyway, if you want to do the table with those, that's an idea for you. Last thing, go back to the graph. Number 2 graph on the handout looks vaguely like this. Which you've probably encountered, perhaps, in an algebra class of some sort. What I've got here at -3, I didn't draw them in there, but from algebra, you might recognize these are asymptotes, vertical asymptotes. I've got a vertical asymptote at 4 and at -3. Well, those vertical asymptotes are very much tied into infinite limits. Because what's my limit as x approaches -3 for this function? Well, as x approaches -3, that's supposed to be a -3 there, by the way. What's happening? Well, from the left, we're going here. From the right, as we approach -3, we're going there. What are they both doing? They're headed down to negative infinity, right? And then at 4, well, what do you see at 4? Well, we don't have a limit as x approaches 4 because one's going negative infinity, the other's going to positive infinity, isn't it? So we couldn't speak about a limit as x approaches 4, but we could say, well, the limit as x approaches 4 from the right, what would it be? Well, 4 from the right, I'm going this, so I'm looking at this side, so it looks like the limit is infinity for that. So that's, on the graph, that's what infinite limits look like. They're these vertical asymptotes. So note here that we have the vertical asymptotes. Vertical are x equals numbers, so the vertical asymptotes are x equals -3 and x equals 4. And notice that's where we have these, that's what we have when we have these infinite limits like this on a function. So if I graphed those other, like here on secant, you may be familiar with the secant graph, but yeah, we're going to have an asymptote at pi over 2. That's what happens when you get these infinite